guys, physics, paper 1A SL, I'm starting with SL this time, and November 2025 TZ3, okay? And let's start with question 1. A stone is released from rest, falls vertically, air resistance is negligible. What is correct about the stone during each consecutive second of its motion? During each consecutive second of its motion, okay. Change in velocity is constant. They're essentially asking, is the change in velocity per second constant? Yes, it is, right? We have an acceleration equal to g, which is constant. And so this is correct, and ideally this should be our answer. Then we have the change in displacement is constant. What does that mean? Change in displacement, s, that's our typical symbol, per second, right, we're saying that is constant. And so we're essentially saying velocity, let's move this up, velocity is constant, which means we have no acceleration. And that is false. Boom. So that's wrong. And so let's cross this one out. Change in acceleration decreases. That means we're saying delta A per second is equal to, is changing, right? It's changing. Decreasing, increasing, it doesn't really matter in this case. But we're saying that acceleration per second is changing. But we know we have a constant acceleration, right? We have this constant acceleration that is not changing. So this one is false as well. Next, the change in speed increases. This is again saying delta V, or delta speed per second, is changing. And that means acceleration, let's just write A, is changing, which is false again, right? We have a constant acceleration. So this is wrong as well, false. This is talking about jerk, but when we have a constant acceleration, we have zero jerk. And so our answer is A. Now we have a projectile is launched horizontally from the top of a cliff with speed 10 meters per second. Projectile hits the ground at a distance of 30 meters from the base of the cliff. What is the height of the cliff? No air resistance. Okay, so now we have to separate this, right? We know the horizontal initial velocity and we know the horizontal distance traveled. So Sx is equal to uxt plus half axt squared, right? But now there's no acceleration in the horizontal direction, only vertically, right? It's being launched as such. And so Sx, so we're trying to find t, and we know 30 over 10 meters per second is 3 seconds. So now we can easily find the height of the vertical distance, sy, traveled, and that is just uyt plus half at squared. And this time we do have a vertical acceleration, but we have no initial velocity, right? We have no initial vertical velocity. So sy is thus just g, and we found t, so 3 squared, and that just gives us 4.5 times 10, 45. Our answer is C. Let's move to question 3. A force is applied to a mass of 3 kgs, variation with time t of acceleration. Okay, what is the average force acting on the mass? Okay, so this is complicated. So we have average force, right? Average is essentially equal to mass times the average acceleration, right? Now they've given us acceleration and this acceleration is changing. So let's find the average acceleration. How do we do that? A average is just this area under the graph, right? And so what is the area under the graph? It's essentially A times T, right? And then we have to divide by total T. So we have, let's divide this. We have 6 times 1, right? I'm just showing all my steps very clearly. 6 times 1, right? Plus, again, this is a triangle, but we can see that it's essentially the same. 3 large blocks, right? So this would also be 6 times 1, but let's do the triangle. Half base into height is 4 times 4. And now we have to divide that by the time. And the time is 6 seconds, which is equal to, so let's write the initial formula. Average acceleration is total area under graph, or let's say divided by total time. And the area under the graph is velocity, right? Change in velocity. So we can write it like that as well. And so what we have is 6 plus 6, is that right? Sorry, no, this height should be 3. So 6 plus 6 divided by 6 is equal to 2, right? 2 meters per second square. And so now we have a mass of 3 times 2 is equal to 6, and our answer is B. Now on to question 4. An object of mass m. Let me just show that again in case. Just go back. An object of mass m moving with a speed v. Object of mass m moving with speed v collides with a stationary object of mass m. Objects stick together, okay. And so what is the change in kinetic energy in the collision? So let's do the conservation of momentum to find the final velocity. So we have mv is the initial plus 0, right? Is equal to 2m. They have stuck together, so there's 2m. M and m, they have the same mass. And we have a v final, right? We don't know what that velocity is. And so now we can say v final is equal to half of the initial velocity, half v. So let's find the change in ke is equal to half mv squared minus the final. Final ke should always be less, right? So we have minus half 2m, and v is half v, right? Squared. So now we have half mv squared minus 1/4, right? These two cancel out, but we have 1/4 here. So just reverse. Okay, we have 1/4 mv squared is equal to 1/4 mv squared, and our answer is C. And that's it for A. Or no, we have question 5 as well. Let's look at this. Pump has efficiency N when raising water from a well of depth B. The mass of water raised per second is R. Changes in kinetic energy of the water are considered negligible. Right? And so what is the input power to the pump? Okay, my screen is working weird. What is the input power to the pump required to raise the water? Okay, so we have power out is equal to efficiency times power in, right? Let's say efficiency is 0.7, right? That's how it works. And so power in, and so what is power? Power is joules per second, right? And that is energy or work done divided by time, which is joules per second. And so let's see how we get that, right? It's raised a certain height or depth, right? And so we use mgh, and we have mass m, and then g is unknown, and we have a depth d. And so we have and per unit time, right? And so looking at this, p in, which is what we're trying to find, is m over t, which we have been told is equal to r, right? Mass raised per second is r. And so times GE divided by efficiency, right? So R GD by efficiency. So our answer is D. And is that all of A? Yes, it is. So that's it for A, guys. And those are the answers.